Welcome to solverfy.
Okay, so first we need to draw a phase diagram of water. We'll have pressure on the left-hand side and temperature on the bottom. So our y-axis is pressure, and it's going to be in ATMs. And our temperature is going to be in degrees C. Okay, so generally the shape of the bubble point is going to go up like this. Okay, and then the dividing line between ice and water is going to go like this. This will be 0.01. Okay, we'll go up to about, let's call this 100 C, 100 degrees Celsius. And let's call this about 1 atmosphere of pressure. And then up here will be about 217 atmospheres of pressure. Okay, so we need to label the triple point. That's just the point at which ice, water, and water vapor are all in equilibrium. So it's the point in which the lines that divide ice, water, and vapor all meet. That's right here. That's our triple point. But TP for triple point. Okay. The critical point is just the highest point on the water vapor dividing line, right? And basically anything past 217 point, this should be like 217.8. Critical point no longer has like a clean dividing line between water vapor and water, so that's why that's your critical point. Okay, and then the other points that need to be labeled here are the normal boiling point and melting points. And what normal means here is just at not room temperature, at atmospheric pressure. That means 1 atmosphere of pressure, right? So to find your normal melting point, you just go into the ice section, you go to 1 atmosphere, and you go to the right, and that's what's going to happen to ice at room pressure or standard pressure as the temperature increases, which is what it means when you go from left to right. So at 1 atmosphere of pressure, ice turns to water at 0 degrees Celsius, and that's about where that lines up. Okay, so that's your normal freezing point or your normal melting point. So I'll put N there for normal. Okay, and specifically that's your melting point, right? Because you're going from ice to water as you go from left to right. Likewise, right, if you're going from water to vapor, that's your boiling point. And so if you go to standard pressure, 1 atmosphere, and go from left to right, you start in water. Well, you go from ice to water, and you keep going right along that same line at 1 atmosphere, and eventually you'll cross over from water to vapor. And ideally, that this should happen right at about 100 degrees C, right? It should match 1 atmosphere of pressure and 100 degrees C should be the dividing line between water vapor, or liquid water and vapor, right? Which we know if you boil water, when it reaches 100 degrees C, that's when it turns from water to vapor. So this is your normal boiling point. Okay, now the unusual feature that water has is the slope of this line, right? Most other substances, the slope will go downward to the left rather than downward to the right. And that's compared to almost every other pure material.